the cache that we have seen so far, we can put the data in any row. And that means we have to check every row when we look for the data. Clearly, since it can be located in any row. But that means we have to have quite a big number of comparators. One comparator for each row. And if we have hundreds of rows or thousands, then it will be too much waste of chip area to use so many comparators. I mean, this chip area could be used in a more clever way to make our programs faster. Okay, so what we can do instead is to limit the number of different places that we can put data. And one approach is to have a function which takes the address and computes a row, a single row. That is called a direct mapped cache. So from an address we somehow map this address to a certain row. And say we have a certain address, and like that, for instance, and we have again 8 rows. So which bits should we use? We should use some bits or any function that is easy to implement in hardware to select a certain row. And the best function is typically to use the last bits. Since if we have 2 variables, they will vary in the last bits. I mean, if they are located close to each other, then they will not be put in the same row in the cache, since these bits will be different. Okay. So how can we compute which row it is? Well, in C, which models this, we can take the number of rows -1 and use bitwise AND. This requires that we have a power of 2 number of rows, which is typically what we want. In hardware, we don't have to calculate anything. We just select these bits and use them to decide which row we are interested in. Okay? And this bitwise AND was explained in a previous video. In lecture 7, if I'm not completely lost. Okay, so what we do first we select the row and then compare this. So how many comparators do we need? Only one, since it's this address and the new address that we are comparing. Okay, so we have saved a lot of hardware. If we are unlucky, there will be, say this is a variable A, and then we have another variable which happens to, well, let's say we write it like that, and then some other bits, and this is address of B. And we write a program that we are very enthusiastic about, that it will be super fast. But we are so unlucky that our 2 variables, the only 2 variables that we have in the program, they unfortunately happen to be placed in the same row in the cache. That can happen. And what can we do about that? Well, we will see that in the next video.